All right, so proving that triangles are congruent. There are 5 different ways to prove that triangles are congruent. And if you haven't looked at yesterday's congruent triangles, definitely go back and look at that. You need to know congruent triangles and what we're talking about before you get into this one. So with congruent triangles, we would have things like a congruency statement that would say that ABC is congruent to triangle DEF. And I gave you that whole congruency statement, and I told you that each corresponding part of congruent triangles are congruent, right? So I gave you 3 sides and 3 angles, which is every part in a triangle. And I told you that all of them were congruent. Now, what we're doing here today is I'm not giving you all 6 things. I'm not giving you 3 sides and 3 angles. I'm only giving you portions of that. I might give you 3 sides. I might give you a side and 2 angles. I might give you an angle and 2 sides. But the only way that we can prove that those triangles are congruent with limited information is with these 5 postulates. So again, this only works if I don't give you all of the topics. So if I gave you these 2 triangles, they look pretty similar, but I mean, we can't go off of looks, right? I can't tell you that that's a right angle. It might be 89 degrees. Until I give you that, now you know it's a right angle. Same thing here. We can't say that these 2 triangles are congruent. So if I only gave you a side, those sides are congruent. If I gave you that those sides are congruent, and if I gave you that that angle is congruent, we still don't know about these other ones, right? We have no clue about them. But today you're going to learn how you can prove that these triangles are congruent. So there's these 5 postulates. I'll stop talking and get right to them. So side, side, side. If you have 3 pairs of congruent sides, so pairs meaning there's 1 pair of congruent sides, there's 2 pairs of congruent sides, and there is 3, then we can prove that those 2 triangles are congruent. They will always be congruent if they're sides, if you have 3 pairs of congruent sides. Now, if you don't have all 3, but you still have an included angle, then you can still do it. So if we have 2 pairs of congruent sides, just like we did before, but then we have an included angle. And what I mean by included is in between. You see how that angle is in between these 2 sides. Well, if I have an angle that is in between those 2 sides, then yes, I can also prove that these triangles are congruent. It's kind of like the example that I just gave above. So that would be SAS, side, angle, side. So angle, side, angle. If I give you 2 angles and a side, that would work as well. So if I gave you these 2 angles and these 2 angles, and let me put 2 of them there, and then now we have an included side. So again, that included means in between. So if we have a included side, then this works as well. Angle, side, angle. Now what I want you to understand is I can't have this side and then this one, right? That angle right, or that side right there is not included between them, so it wouldn't work. So there's a little hint for a problem later on. Be careful to make sure that both of them are included in between the 2 angles. We also have angle, angle, side, which is 2 angles and a side opposite them. In other words, the side is not in between them. So if we have these 2 angles, or 2 angle pairs, it doesn't matter which one. I'm just using these as an example. And we have these sides, this pair of sides, then we can also say that angle, angle, side works, and we can also prove that those 2 triangles are congruent. Doesn't matter if you know the other parts or not, they will always be congruent. And lastly, hypotenuse legs. So if we have the hypotenuse, if we know that both of them are congruent, and we have any one leg of any right triangle, it could be this one, it could be the other one, but as long as they correspond, and we have those 2 pairs of sides in a right triangle, then we can also say that that triangle is congruent. Now, these are the only 5, okay? So be very careful with this. A lot of times people will get these mixed up, especially this one. They will say angle, angle, side, and they'll say, well, no, that doesn't work because it's side, angle, angle. And I say, well, hey, look at it backwards. You know, side, angle, angle is the same as angle, angle, side. Lastly, you notice that there's one thing that's not on here, which I think is hilarious. Some people will say, well, what about side-side angle, right? Does that work? And in Math 2, no, that does not work. And I'm not going to go into the proof where it works sometimes and it doesn't. Just for reference, in Math 2, it doesn't. Because if you spell side-side angle backwards, that is a word that we do not use in class, and that is a postulate that we do not use in class. So there's no such thing as angle side-side, and when you think about it, you kind of get it, okay? So that's a good way to remember there's no angle side-side. All right, so reason sides are congruent. So it could just be given. They could just tell you, hey, side AB is congruent to side AB. And they're not lying to you. You just take their word for it, okay? There could also be a midpoint. A midpoint will create two congruent sides. So if I gave you something like, maybe a diagram like this, and those triangles shared a side, and I said this was A and B, and C is a midpoint, right? If C is a midpoint, then we know that those two sides, AC and BC, are congruent, even though we may have two separate triangles, right? One there and one there that are just putting back to back. But we still know that that would be a pair of congruent sides. Also, reflexive property, a side is congruent to itself. So you see this side right here is being shared by both triangles. Well, that side would be congruent to itself. That would be just as if we had two triangles like this. And we just kind of move those triangles apart. Well, that side would be congruent. If it's together, touching, like it is here, then we know that that side is congruent. All right, so that's sides, but then we have a lot of reasons that angles could be congruent. First off, it could just be given. They could say that angle A is congruent to angle A, and you take their word for it. They're not going to lie to you. Vertical angles. You guys remember vertical angles? You might have something like this, where we know that these two angles are vertical angles because they're across from each other in an intersection. All right, but then we have all sorts of other ones too. So we could have, let me just go ahead and do this. I will extend this on. And you see how that is a transversal, right? So we have our two parallel lines and then a transversal cutting across it. So these two angles right here would be alternate interior. So that's a way that we would know that they would work. You could also have alternate exterior angles. That would be perfectly fine as well. And the reason I put that is because if you draw this line over here, now you can see how we have one triangle and two triangles. So that will be a way that we find angle pairs. You could also have corresponding angles, right? So we would know that corresponding angles would be congruent. That would be more on a triangle where we had something like this. And then, let me see how I do this. Yeah. So it would be kind of like this. If you had those two triangles that we're talking about, so I can kind of erase these. And we know that these two lines are still parallel, right? And here's our transversal. We would still be able to say that these two are corresponding because they are both in the top right of this intersection. So you have this intersection here and this intersection here. They're corresponding because they're both in the top right. So that would be corresponding. And then you can also have the definition of an angle bisector. So an angle bisector would create two congruent angles. And that would be if you had two triangles like this. And if you said that A, B, C, D, you could say that DC is an angle bisector of the angle ACB, right? So in other words, it cuts C into half. So those will be two congruent angles. So that's how you could know that those two angles of the triangle are congruent. If you ever get stuck on any of the diagrams like this, it's always helpful just to write them side by side. I think that really helps you see the two different triangles if you can't already. And then CPCTC, that's just the corresponding parts of congruent triangles are congruent. That's just the angles that are congruent to each other. and the sides. So AB would be congruent to DE, BC would be congruent to EF, and AC would be congruent with DF. Again, go back and look at that lesson if you need to, but it's all about your congruency statement. Okay,